Okay, so we want to evaluate this integral, or show it diverges. So again, there could be two problems with the integrand. There's going to be a discontinuity when x is equal to 0, and that's really if we well, let me just do a little scratch work here because we're going to need it later. If I look at the denominator here, I can factor this as the square root of x times 1 plus x. And of course, 1 plus x is going to be equal to 0 when x is equal to minus 1. But if x is equal to minus 1, the square root things don't make sense. But in either case, this integrand is going to be discontinuity, is going to be discontinuous at 0, and it's not going to exist when x is less than 0. But we're only integrating from 1 to infinity. So this is just a type 1 improper integral, meaning the only issue that we have to take care of is taking the limit as r goes to infinity. Okay, so the integral from 1 to infinity dx, I'm going to go ahead and factor out a square root of x. So this is the square root of x, 1 plus x, is equal to the limit as r goes to infinity, 1 to r dx over the square root of x times 1 plus x. Okay, now I think this is a somewhat tricky integral to do here. Maybe you think it's easy. Maybe you'll have an even better way to do it than I'm going to do it. But think for a minute how you might approach this problem. Okay, so I'm going to make a u substitution. I'm going to say u is equal to the square root of x. And if u is equal to the square root of x, this means du dx is equal, so remember this is x to the power of 1/2. So du dx is equal to 1 over 2 times the square root of x. Or this tells me that 2 square root of x du is equal to dx. Okay, and now in my integral here, I'm going to make these substitutions. So I've got the limit. Again, the limit, we're not doing anything with it yet other than just writing it down because this is a perfectly well-defined integral. So now I'm going to do this integral. So my lower limit is going to be the square root of x. So the square root of 1 is 1. My upper limit is going to be the square root of r. So that's r. Okay, now my integrand is going to take me a couple steps to get the integrand how I want it to be. So first of all, dx is equal to 2 square root of x du. Okay, I'm dividing. I see a square root, so I'm going to go ahead and replace that with a u. And then I've got 1 plus x. I'm going to have to figure out what to do with this stuff here. This is equal to the limit as r goes to infinity. Okay, so let's see what's happening over here. Maybe you already recognize this, but u is equal to the square root of x. So this is the square root of x, and I'm dividing by u. So those are going to cancel. I can pull my 2 out. In fact, I'm going to pull this 2 not only out of the integral, but outside of the limit. So I'm going to have this, and I'm going to have the integral from 1, sorry, this lower limit here is 1, from 1 to the square root of r. So the 2 came out there. I've got the square root of x. The square root of x is equal to u, so these two guys are going to cancel. And I'm left with du over 1 plus x. But if I come over here, if u is equal to the square root of x, this means, if u is equal to the square root of x, this means x is equal to u squared. Okay, if u is equal to the square root of x, this means x is equal to u squared. And so now I'm going to have 1 over 1 plus u squared. Okay, so this is equal to 2 times the limit as r goes to infinity. Okay, so I can do the antiderivative. The antiderivative of 1 over u squared is arctan u. So this is going to be the limit as r goes to infinity, arctan of u, and I'm evaluating this from 1 to the square root of r. And now this is going to be equal to 2 times the limit as r goes to infinity. I'm going to have arctan of the square root of r minus arctan of 1. So think for a minute about what the arctan of 1 is. So I'm going to have 2. Now the limit as r goes to infinity of arctan of the square root of r, well, this is going to be equal to pi over 2. So remember, as x goes to infinity, arctan of x goes to pi over 2. And as x goes to negative infinity, arctan of x goes to minus pi over 2. But this limit right here is r goes to infinity, the square root of r goes to infinity, and so arctan of the square root of r goes to pi over 2. Arctan of 1, this is going to be, let's do a little side computation over here in case you forgot. We want to know when tan, let's say tan of theta for now, is equal to 1. This is the same as sine theta over cosine theta is equal to 1. And this is the same as sine theta equals cosine theta. And so we see pi over 4 is the solution here. So arctan of 1 is pi over 4. Okay, pi over 2 minus pi over 4 is pi over 4. You multiply it by 2, and you get pi over 2. And so the value of this integral is pi over 2. Okay, and there we have it.